Hi everyone, let's go through some indices and index laws. First I'm going to go through some notation. So we have here 2 to the power of 3. So all these in what's circled, it's called index form. Number 3 in the power, it's called either exponent, index or power, and number 2 is called the base number. So 2 to the power of 3 can be expanded and written in form 2 times 2 times 2. So, and even though this is not that long, but some numbers are much larger, it is very convenient to write in index form. So here we have some index laws. The first one that we usually put is multiplication one. So if we, for example, have a to the power of m times a to the power of n is equal to, please note we have to have the same base. In this case, this is a, we have to have same base. We copy the base, and then what we do with the powers, so we add them together. Let's have a look at example here. So 3 to the power of 2 times 3 to the power of 4 is equal to 3. 2 plus 4 is equal to 3 to the power of 6. Pretty much what we're doing here is saying 3 times 3, then times 3 times 3 times 3 times 3. See how, not really annoying, but, we're just repeating the same thing over and over. So therefore it is easier to apply index law and just go like, okay, 3 to the power of 6. The next one that we have here is division one. So we have a divided by to the power of m divided by a to the power of n. It could be simplified in index form again. So we have to copy a or the same base. So it has to be the same base. And then what we do with the powers, the first one from numerator above the line, take away the power in denominator below the line. So let's have a look at example. So 5 over 3 to the power of 2 is copy the base. 5 take away 2 is equal to 3 to the power of 3. So you can do the similar what I have done for multiplication to, for example, have this. Let me just use different color. For example, this 3 to the power of 5 have written as 3 times 3 times 3 times 3 times 3. I think that was 5 times already, divided by 3 times 3. Okay, actually I'm gonna do it from here. Okay, I'm just gonna go here and then look. Okay, 3 times 3 times 3 times 3 times 3 divided by, we have 5 there, 5 threes, and then 3 times 3. So the first thing which we can do here is cross out, cancel out 3. Oopsies, not like that. So I'm gonna use again different color. 3 divided by 3 is 1, so that's why we can cancel out. 3 divided by 3 is equal to 1. So what we are left with is 3 times 3 times 3, 3 lots of 3, which is 3 to the power of 3. So the next one that we have, I need another color here. So this one here, it's the law raising a power to a power. So we already have a to the power of m and then again to the power. Simplified version is a m times n. So if you don't have sign here, it means m times n. So let's have a look at example. I'm just trying to, so it's like here, 3 to the power of 2 to the power of 4 is 3. 2 times 4 is equal to 3 to the power of 8. So again, you can do similar what we have done with multiplication and division. and see how actually it works out. So let's have a look what we have next. So on the next page, on this page, we have more laws. So what we have here, multiplication raised by power. So you have multiplication, A times B. Again, if you don't have sign between A and B, it means times, and then to the power of n. So what we have to do is actually all members inside the brackets needs to be raised to the power, every single one. Again, okay, have a look at example. So when I have 3x everything to the power of 2, so every member, so there's like 3nx, 3 to the power of 2, x to the power of 2, and if you can simplify, you can just go like this. If not, you can just leave it. Next one, we have division raised to a power. So it's similar as multiplication one, but we have to have a look. So we have A divided by B, and then everything to the power of n. So every single member inside the brackets needs to be raised to the power, A to the power of n, B to the power of n. Please note we have here B can't be equal to 0. Remember just that we can't divide by 0, that's why it can't be equal to 0. So let's have a look at an example. So 4 divided by 3 to the power of 2 equal to every single member inside the brackets needs to be to the power of 2. And this one is going to be 16 over 9. So I'm going to have another example with this. So if you have, for example, 3c divided by b and everything to the power of 2, so every single member inside the brackets, in this case is 3 to the power of 2, c to the power of 2, and b to the power of 2. Again, you can simplify this or you can leave it as it is, depends what you have been asked to do. The next one that we have here is zero index law. So I really like this law. A to the power of 0 is equal to 1, A can't be equal to 0. For example, 5 to the power of 0 is equal to 1, anything to the power of 0 is equal to 1. I just love this one because sometimes I need number 1 and it can be written like anything, like 4 to the power of 0 is equal to 1, 1/2 to the power of 0 is equal to 1, etc, etc. So by the way, let's say here hashtag love maths who doesn't, hashtag love maths who doesn't. Okay, let's go back to the next one. So now we have negative index law. So for example, a to the power of negative m is same as 1 over a to the power of m. I'm just gonna add here, so pretty much it's like this, that one. Please note that this one and this one not the same, not the same one, okay? So let's go with example straight away. So let's have a look. 2 to the power of negative 3 is equal 1 over 2 to the power of 3. So that's the one. So the next one we have a over b, then brackets, everything to the power of m equal to, so if we move a from numerator to denominator, is going to change, it's going to become negative. Let me have a look. Yes, yep. So I'm going to add here as well, like just something, I think it's going to make more sense. So if I have and it pen a to the power of m, b to the power of m, and then if I swap the numerator and denominator, is going to give us b to the power of m and a to the power of m. So I guess I'm going to have example for this maybe on the next page. There's not enough space. And now the next one, we have a divided by b to the power of m. A is positive. We're not going to do anything with it, but we're going to move b to the numerator. So because it's negative in the power in denominator, so it becomes positive. Again, I'm going to add here something as well from here. So it's like written a over 1 times 1 over b to the power of negative m. It's equal to a over 1 times b to the power of m, and then it goes there. Okay, let's go to next page. So I don't have any questions ready on this page, but I'll just pick some, I guess. So what we can do, should I start with the simple one? Okay, I'm just going to go like this. 3 to the power of 2 times x to the power of 3 is equal to, what can we do with this one? So we do know we have to have the same base. Do we have the same base? No. All we can do is just leave it as it is. Okay, so we can't apply index law. So we have to remember that we have to have the same base. Let's have a look at this one here. X to the power of n. Do we have the same base? Yes, we do. Copy the base and add powers. Beautiful. So second one, if I have t to the power of 6 divided by t to the power of z is equal to, copy the base, we have the same base, beautiful, and then 6 take away z. So that would be the answer for that one. Next one. What can I write? So maybe 4x to the power of 2, 4 to the power of 2, x to the power of 2, 16x to the power of 2. More, I'm gonna have, for example, which one can I pick? 3b divided by c, and then everything to the power of 2. If you remember the rule from previous 2 pages, 3 to the power of 2, b to the power of 2, every single member inside the brackets needs to be risen to that power. So if you want, you can simplify this like that. Okay, have more a. I'm not going to go with a. Then you may think that I can only use a. You can use any letter, anything. P divided by 3 to the power of 2. It's p to the power of 2, 3 to the power of 2. Again, you can simplify, depends what you have been asked. Next one. So we're going to have 3x divided by 4y, everything to the power of 2. Again, oopsies. Again, everything to the power of 4, every single thing. And then again, if you want to simplify, you can do so. Keep going. 7, so 10x. By the way, I'm doing this, my year 10s are gonna have test on this. This is gonna be the part in the test, so just to make sure they have something to revise, and then we don't have to simplify that one. It's gonna be 10 They're going to be 5 zeros, so we're just going to stop there with that one. Okay, now let's have a look at something that we haven't done before. So if you have a question like this, because it's multiplication, so remember in multiplication A times B is the same as B times A, so we can swap it. So what's happening here, we can have 4 times 2 next to each other, then B to the power of 2, B to the power of 3, okay? Still the same expression. 4 times 2 is 8, B and B same base, copy, and then we add indices, 2 plus 3. Then it's equal to 8b to the power of 5. I hope that's right. So didn't. So let's have a look at this one here. A to the power of 2. Have we done something like this? We had something similar. So I'm just gonna, oopsies, get rid of that one. We had something similar. Similar. Let me think. Something negative. Okay, let's have a look at negatives. Okay, 9. So 6 to the power of negative 1 is 1 divided by 6. A 6 negative 1 times A is A divided by 6. The point is again that this one and this one, they are not the same. So this one, negative 1, becomes positive and is here. Okay, so just make sure we remember that. Then 10, question 10, 5, 3 to the power of negative 1 is, we can just flip it, 3, 5, but remember to change the power, just 3 over 5. I'm trying to think any other questions. Should I do more or not? Okay, I'm gonna do this one because I have seen kids making mistake here. For example, 3 times 4 is equal 3 times 4 to the power of 0 is 3 times 1 is equal to 3. And sometimes we have 3 take away 4 to the power of 0, 3 take away 4 to the power of 0, yep, 3 take away 1 is equal to 2. So I think this would be all for this video. Maybe one more. Let's do one more. 7a to the power of negative 1 is the same as 7 over a. Or 7a negative 1 is the same as 7 times 1 over a. And I think that would be it. Okay, smiley face, and I see you in the next video. Thank you. Bye.